కింద తీసుకెళ్ళు లైవ్ స్ట్రీమ్ స్టార్ట్ అవుతుంది. Yeah. Good evening, everyone. Welcome back to 360DigiTMG's Domain Analytics program. From yesterday, we have started the Web and Mobile Analytics program. If you haven't watched the previous video, the very first video of Domain Analytics, that is Web and Mobile Analytics, you can simply go to YouTube channel of 360DigiTMG and you can watch it. So in yesterday, in the very first session, we have discussed where exactly we can apply the machine learning algorithm. Where exactly we can apply machine learning algorithms. So that we can improve the sales of different products. What are the advantages we'll be having when you apply the machine learning algorithms? That also we have seen. And today's we will be discussing about what will be the phases. What are the phases we'll be having whenever we are working on the data science project. So it is irrespective of domain. Domain could be anything. That could be agriculture. That could be HR. Domain could be anything. But the process that we will be following will be the same. The same phases will be following to implement the data science project. That is called CRISP-ML. CRISP-MLQ. That is cross-industry standard process. Cross-industry standard process. ML means machine learning and quality analysis. So why we are following this particular standard only? Why can't we follow others? In order to get better accuracy, so we'll be following the cross industry. It is not just for us. It is internationally recognized. So we will be following the cross industry standard process algorithm or the phases. What are the phases we'll be having? What is the agenda for today's topic? We'll discuss first. Stages of analytics. What stages will be having whenever you are doing the data science projects that we will be discussing. And CRISP-ML methodologies, of course, cross-industry standard process, machine learning quality analysis methodologies. In that, we will be having 6 phases. What are those phases is about? What we will be doing in different stages that we will be discussing. And in that, we'll be having something like supervised and unsupervised machine learning models. When it comes to machine learning models, we'll be having 2 categories. One is supervised, and one is supervised and unsupervised. And then how we will be doing the data split. What happens when we are using the unsupervised models? What happens when we are using the supervised models? That we will be discussing. And once the model building is done, we are supposed to see how good your model performing. In that, we have to have some evaluation metrics. We'll be having 2 types. That is one classification case, regression case. In that case, we'll be having different evaluation metrics. We will be discussing about that too. And overfitting and underfitting. If it is whatever the model that you are building is fitting perfectly, or do we have anything biased model, something like if it is not performing well, what could be? It is training accuracy. What is the testing accuracy? If it is if it doesn't have any match in between training accuracy and testing accuracy, in that case we might get into the overfitting issues or underfitting issues. What exactly are those? All those things we will be discussing in today's session. First, when it comes to stages of analytics. When it comes to stages of analytics. Here will be any stage, that could be anything. I mean, any domain, like I've discussed earlier. It could be any domain, but you'll be having the same stages. Here, when it comes to stages of analytics, we'll be having 4. The sequence is very important here. You can simply remember D square, E squared. That is a descriptive analytics, diagnostic analytics, predictive analytics, and the prescriptive analytics. What exactly the descriptive analytics, what we will be doing when it comes to this stage? Here we'll be talking about what exactly happened. What happened? If you have some problem statement, first we have to see what happened. And then we'll be looking into diagnostic analysis. We'll be doing the diagnosis. Why this happened? Whatever happened, why something has happened. Predictive, we'll be doing the prediction. We're using the machine learning model. We'll be doing the predictions. What will happen? Now, what is likely to happen? With that, what is likely to be happen? What can be done, like business decision? What are the business decisions that we can take here? What is to be done? Whatever the problem statement, I mean, any domain. So first we will be looking into the problem statement. What happened? Then we will be getting into the data and we will be doing the analysis. Based on data, we can find out why something happened. What is the reason behind it? If you have data about the whatever the thing happened, you can easily find out the inferences from the data. Whenever you're doing the analysis, you will be doing if you have any anomalies in your data, in that case you will be cleaning it. Then you will be doing the visualization. From that, we can easily find out why something happened. So in order to avoid that, what we can do, what is likely to happen, that we can do using the predictive analytics. We will be building the machine learning models in this stage, and we will be doing the predictions. Based on those predictions, we can take business decisions. Here, the last stage, that is a prescription. In this, we can take the business decision. Let's say, let's apply in the real time. You have fever. You have fever. What you have to do? You have went to doctor. He will ask what happened. Then you will be saying like, yeah, I have a fever. Why it is happened? Do you have any reasons? He will ask you if you get a few questions. Do you have any mosquitoes around you? Or do you went to somewhere else, that is weather is completely different? So these kind of questions he will be asking. With that question, he'll try to do some assumptions. If it is whatever the assumptions is making correctly, in that case he will do prediction, like maybe because of mosquitoes you might be having the fever. Something like that, he will come to the conclusion, and based on that, he will be giving you the prescription. If you have the fevers because of weather, in that case, he will be going for some drugs. And if it is something related to something mosquitoes, in that case, he will be going for different drugs. That is how we will be taking the decisions based on stages of analytics. That could be anything, any domain. We will be doing the same stages we'll be having. Yeah. Project management methodologies. Here we'll be having the CRISP-ML. Previously, we used to have a CRISP-DM. That is same cross-industry standard process. Cross-industry. It could be any industry or any domain. Will be the same. And here it is data mining we used to have, but in that we won't be having monitoring and maintenance. So we have replaced that CRISP-DM methodology with CRISP-MLQ. In CRISP-MLQ, we will be having the 6 stages. One is business and data understanding, and then we'll be having data preparation, and then we'll be having model building and tuning. And then we'll be having the model evaluation. What will be happening when it comes to the business and data understanding? Whenever the data, the problem statement is given, you should be having an idea of what exactly the problem statement is talking about. What could be the business objective? So you need to set this first. What could be our business objective? Based on that, we will be going for the model. In business understanding, you should know what are the business objective and what could be the business constraint. What could be business constraint? Once you have an idea about what could be the business understanding and constraint, you can simply go with data understanding. You have to know the detailed description about the data. If you have a domain understanding, in that case, you can simply go with the data preparation. If you don't have knowledge about the domain analytics, in that case, you can simply research about that particular features. Different features will be having in data frame. You can simply do the research. And once it is done, you can go with the pre-processing. See, whenever you are getting the data, that should be raw data. In that case, you will be having so many anomalies. You might be having outliers. You might be having missing values. You might be having NA values. In that case, we have to do the data preparation. In this data preparation, we will be cleaning the data. If you have missing values, in that case, we will be doing the missing value imputations. Then we will be going for the model building. Once the data preparation is done, we can simply go with the model building. In those model building, we will be having different something like supervised, unsupervised. There are different model buildings. Based on your data frame, you will be selecting whether you should go for unsupervised or you should go for supervised. We will be deciding based on the data itself. Then once the model building is done, you will be doing the tuning. We will be having hyperparameter tunings. Based on that, you can find out whichever the parameters performing the best. Using those parameters, we will be doing the tuning so that we can improve the accuracy of that particular model. Once the model is done, then we will be going for model evaluation. Whatever the model that you have done, is it performing good or not? Is it fitting perfectly into the data or not? These are the evaluation we will be doing. In that, we will be having different classification, regression for each. We will be having different evaluation metrics. Then we will be, once the evaluation is done, if everything is good, in that case, we can simply go with the deployment. Deployment, we will be doing using different techniques, using the Flask, we can Django, we can do local server, that is a Streamlit, to check whether it is working perfectly or not. And then once deployment is done, you can do monitoring and maintenance. These are the 6 phases we will be having in every data science project. So these are the phases we will be having. What business understanding and data understanding, and then we will be going for data preparation, model building. If it is not the case, in that case, again going back to the data preparation. And then once the model building is done, we will be going for the model evaluation. If model is not performing well, in that case, you have to go back to the business understanding. You might have missed something from the data, or you might not have feature of interest. In that case, you have to go back and you have to collect the data. Once the testing is successful, you can simply deploy and you can do monitoring and maintenance. These are the phases we'll be having. So when it comes to model building, we will be having 2 types. One is unsupervised learning, and we'll be having supervised learning. Whenever we are talking about the model, we'll be having 2. One is supervised, one is unsupervised. What could be the case on how we will be doing the training and testing when it comes to unsupervised learning, and how we are doing when it comes to supervised learning, that we will see. Yeah. When it comes to unsupervised learning, what we will be doing, simply right after doing the pre-processing, you can simply feed the data to machine learning algorithm. Once you've fed the data to the machine learning algorithm, in that case, it will come up with some rules and patterns. We won't be having, we don't need to split data into train and test when it comes to unsupervised learning. You can directly build the model, something like clustering. So based on the machine learning itself, figured out what are the patterns we'll be having in our data set. Based on those patterns, it will come up with different rules. And then same rules we'll be using to do the prediction. We will be applying this new inputs, and based on those rules, we'll be splitting into different categories or segregation you will be doing. So this is all about once the rule pattern is generated, you can simply the same using the rules and pattern, you can simply give a new data to the algorithm. Based on those rules and pattern, it will split into different segregation or different categories. If you are doing the clustering, in their case, different clusters, those will be. So it is very simple when it comes to unsupervised learning. And then we will be having supervised learning. Whenever you have a supervised learning, the data right after, so whatever the model that you are applying or the machine learning algorithm that you are applying, everything is after doing the pre-processing only. Once pre-processing is over, cleaning of the data is over, then only we will be feeding into the model or we are training the machine learning algorithm. Historical data, and what we are doing when it comes to supervised learning, we will be splitting the data frame, whatever the data frame we will be having, into training and validation, or you can use testing as well. So you have to split into training into testing data. You can say here testing. It could be anything, like if you have a maximum number, or like you have 100,000 columns or 100,000 entries, in that case you can go with 90%, 10% as well. But normally we will be going with 80%, 20% split. So training data into 80% and the testing data or validation data we are doing with 20% data. So whatever the model that we are building, we will be training on training data. This is a machine learning model. We are training the machine learning algorithm using the training data set. Once we have trained the data set, and then we will be forming some mathematical equation with using the machine learning algorithm. Then we will be applying the validation data to the same machine learning algorithm to check the outputs. Whatever the output that we are getting are similar to our previous the real data outputs are not. We will be doing the cross check, or you can say whatever the model that we have built, we'll be applying the new data, that is the validation data, and we'll be checking the accuracy, or we'll be getting the output. Then what we'll be doing, we'll be checking both in the data frame, you'll be having the real values and you will be having the predicted values. Those are actual values and the predicted values. If you have hyperparameters when it comes to machine learning, if you have more hyperparameters, in that case, what you can do, you can split the data frame into train, validation, and test. We'll be the training the machine learning model using the train. And if you have a good number of hyperparameters, in that case, you can simply use validation data set to tune your hyperparameters. Once everything is set, in that case, you can combine both and you can simply apply the testing data to check the accuracy of the particular model. Here, since model is done, in that case, you can apply the new data set and you can do the prediction outcome. You can predict the output of the particular model. Same supervised model. What we will be doing will be whatever the data frame will be having, will be splitting into train, validation, and testing. Whichever the model that you are building, you should be training with the training data. We will be training using the training data, and we are building the model. And if you have a good number of hyperparameters, in that case, we'll be applying the validation data and to check different hyperparameters. But what exactly we are, how much accuracy that we are getting with different hyperparameter tunings. Whenever you in this process, there is a chances of that validation data might leak. So it might create bias. in that case, what we'll be doing again, we'll combine both, and then we are supplying the new data, that is the testing data, to check the accuracy of the particular model. Now we can say that, yeah, whatever the new data that we'll be applying to the machine learning model, still if it is performing well, in that case, we can say that, yeah, it is a good model, since we don't have any leakage. When you have a hyperparameter tunings, then there is a chance that when you still, I mean, you continuously you are changing, checking whether which hyperparameter is working best. In that case, there is a chance of leakage of data. That is why we already, kept the testing data aside to check the model accuracy. So this is how supervised model builder, supervised model evaluation will be done, and hyperparameter readings. Supervised algorithm. So when it comes to error function or confusion matrix, it is the evaluation matrix when it comes to classification case. So we'll be having classification when it comes to supervised. We'll be having regression. These are different machine learning models. Whenever you have data set with output as a categorical data, COVID, yes or no. It is a categorical data. If it is 0 or 1. When you have output something like that, in that case, we'll be going for the classification. When you have a continuous data in output, in that case, we'll be going for regression. So this is the error function for confusion matrix. That is the evaluation matrix for classification case. Once the model building is done, to check the accuracy of the model, we will be having confusion matrix when it comes to classification case. Confusion matrix is an evaluation matrix for classification. So what we'll be having when it comes to confusion matrix, we'll be having actual cases and the predicted cases. So whatever the whenever you are building the model, you will be having actual cases and you will be having the predicted cases. With using those data, we have to tell what could be the accuracy of the model. How many classes? Classes means the output. Whatever the values or the output will be having labels, that will be calling as a classes. Yeah. So how classification is done? How many of the cases we have correctly classified? How many of the cases we are falsely classified? All those things will be having in a confusion matrix. Here, these are the predicted cases and these are the actual cases. Let's say actual case is the testing positive and you are also predicting as a positive. In that case, we'll be calling it as true positive. When actual case is also positive and you are predicting as a positive, in that case, we'll be calling it as true positive. True positive. But when it comes to actual cases are negative, but you are predicting as negative. In that case, we'll be calling as true negative. When actual case and predicted case both are same, both are positive, in that case we'll be calling that true positive. When actual cases and the predicted cases both are negative, in that case we'll be calling it as true negative. If actual cases are negative but you are predicting as a positive, when actual cases are negative but you are predicting as a positive, in that case we'll be calling it as false positive. Well, actual cases are negative, but you are predicting as positive. In that case, it is called as a false positive. If it is vice versa, I mean, in the reverse, in that case, we'll be calling it as false negative. If actual case it is positive, but you are predicting as a negative, in that case, we'll be calling as false negative. These are the different cases we'll be having. True positive, patient with a disease is told that he has a disease. So actual case is also patient has a disease, And the predicted case is also patient has a disease. In that case, we will be calling it as a true positive. With actual case is a no disease, and the predicted case is also not having disease. In that case, we'll be calling it as true negative. False negative, patient with the disease is told that he doesn't have a disease. In that case, we'll be calling it as a false negative. So using this, we will be calculating the accuracy of the model. How can we calculate that? Accuracy of the model is equal to true cases, all the true cases, that is true positive plus true negative by total number, that is true positive plus false negative, false positive plus this. Accuracy is equal to true cases by total number of cases, or you can say error 1 minus accuracy. If you consider total 100 is equal to accuracy, error is 1 minus accuracy. So whatever the model that we are building, we are considering the maximum accuracy is equal to 100. Maximum accuracy is equal to 100. If you know the accuracy of the model, in that case, you can easily find out the error of that particular model. So these are the confusion matrix or evaluation matrix when it comes to classification case. So when you have unbalanced data, you can't really directly jump into what is the accuracy of my model. So whenever you have unbalanced data, you should go for F1 score. What is the F1 score? It is a combination of both precision and recall. The formula for F1 is equal to 2 into precision into recall by precision by recall. If you don't know which one you have to consider, whether you should go for precision or you can go for recall. If you are not able to differentiate, in that case you can simply go with F1. It will balance both precision as well as recall. What exactly the precision and recall? Here. Yeah. Precision is true positive cases by true positive plus false positive. Let's say you have built a model and you have deployed it. Probability of correctly identifying the random patient with the disease having a disease. Once you have deployed the model, then we will be giving the new different entries, right? So what is the probability of correctly identifying the random patient? That is a random. It is not given in our data set. So we'll simply taking the random patient with the disease having a disease. That is called as a precision. When it comes to sensitivity, or you can also call it as recall or hit rate. Hit rate. That is a true positive by true positive plus false negative. In that, we will be having data set. In that, we will be having positive cases, right? And negative cases. Both will be having. Among those positive, how many of you correctly classified as a positive? Among those positive cases, how many of you correctly classified it as a positive? That is called as a sensitivity. When it comes to specificity, among the negative cases, whatever the negative cases we will be having, how many of you correctly classified as a negative? How many of you correctly classified as a negative? That is called as a specificity. Yeah. So that is a precision, sensitivity, and the specificity. FP, false positive rate. What is false positive rate? 1 minus sensitivity. Sensitivity is what? Recall or hit rate. Recall or hit rate. It is what? Among the given positive cases, how many of you correctly classified as a positive? These are the difference between precision, recall, specificity, and sensitivity. Whenever you have unbalanced data, instead of directly going for accuracy, you have to go for F1 and specificity. F1 ratio you can go for. Yeah, when it comes to regression cases, you will be having evaluation metrics. Different evaluation metrics will be having. What is regression? Whenever you have a continuous data, whenever you have a continuous data in output column, whenever you have a continuous data in output column and you are doing the prediction, in that case will be considering as a regression case. In regression, we'll be having evaluation metric, something like mean error, mean absolute error deviation, or mean squared error, root mean squared error. These are the different evaluation metrics we will be having when it comes to regression. So mostly what happens, why we are using this, why can't we use directly calculate the difference between two errors? So let's see, this is actual data. You'll be having this actual data. And this is the actual values. These are the predicted values of model 1. Whenever you are calculating the mean of all the errors, whenever you are calculating the mean of all the errors, it will always become 0. Will always become 0. When it comes to model 2, you can check these are the actual values and these are the predicted values. When you find the difference and the mean of all the values, it is always equal to 0. 1, it is 0. Here also it is 0. To avoid that, mean of the, so you have an error, but it is showing no error when you are calculating the mean. To avoid that, we will be having the mean error will be getting 0. To avoid that, we will be going for mean square error. So instead of directly taking, we will be squaring those errors. We'll be squaring those errors. Whenever you're doing the squaring of those errors, what happens? Whatever the error, you'll be having just here, you can say square, in that case 100. Square, in that case, it is also 100. Square, in that case, it is also 100. It is doubled normal to our error. In that case, what will be to bring down to actual number, will be doing the square root of those number. That is where we'll be using the root mean square error. So most of the time, whenever we are having the regression cases, we'll be going for root mean square error. It is the only evaluation metric that will give you exact error. What is error? It is the difference between actual and predicted cases. Here, accuracy plus error, you will be getting the 100%, right? So accuracy and error is always equal to 100. To judge the accuracy of the regression model, we will be having something like R2 square, coefficient of determination. This value ranges from 0 to 1. If you have 80% and more than that of the R square value or R2 value, in that case, we'll be considering that as a good model. So these are the evaluation metrics when it comes to classification case and when it comes to regression case. Yeah. Okay. So whenever you are working with the classification cases, you might be finding the something like overfitting classes, overfitting machine learning algorithms. Especially when it comes to decision tree, we will be calling it as a bound to overfit. Since decision tree, what happens in decision tree, it will go through each and every data point of the data set. So it will be learning all the data points. So if you apply training data on the machine learning algorithm, it will simply learning the data. In that case, what happens? You'll be getting 100% accuracy when it comes to training data. But if you are applying the same thing or same machine learning model with the testing data, it won't be performing well. It won't be performing well. This case is called as an overfitting case. Whenever you're having training accuracy is high, and testing accuracy is low. In that case, we will be calling it as overfitting case, or you can also call it as variance. Overfitting case, you can also call as a variance. Whenever you have an accuracy of the test, accuracy of the training data itself low. Accuracy of the training data itself low. In that case, of course, you will be having the less accuracy for the testing data as well. So in this case, we'll be calling it as underfitting. Underfitting or bias. When the training accuracy of the model is high and testing accuracy of the model is low, in that case, we'll be calling it as overfitting case. When training accuracy itself low, in that case, we'll be calling it as underfitting. So what we have to do when in these cases, you have to do whenever you have the overfitting case, you have to go with regularization techniques. And whenever you have underfitting cases, in that case, when training data, training accuracy itself low, in that case, what you can say, whatever the data frame or the feature that you are taking to do the prediction of that particular output, it is not sufficient. Whatever the feature that you are taking, those are not exact feature. You might be needing something useful features. In that case, we can add the feature into our data frame or the model, and you can improve the accuracy of that particular model. So you can see here. Yeah, in regression, these are the data points we'll be having. So it is not a linear model at all, but you are trying to apply the linear model. In that case, it will be the overfitting case. So it is underfitting. It is underfitting case. It is not linear at all, and you are trying to fit it to linear. In that case, it will be an underfitting case. The accuracy will be low, very low. Training accuracy or the testing accuracy, both will be low. If you are trying to apply the same, if you have a linear, non-linear data, in that case, you are applying the non-linear model only. In that case, you might be getting the good fit. It will be calling as a good fit. If you are touching through each and every point, wherever a point there, you are going and touching that particular point. In that case, model is not learning, it is simply copy pasting it. In that case, we will be calling it as overfitting. This is the overfitting case. It is when you have a regression. When it comes to classification, so when you have just two classes, in that case, what we will be doing? Simply using one line, we are segregating into different classes. So it is a very basic model. It is very basic model. It is underfitting. Underfitting because accuracy of training is not that good. You aren't doing any model build, any hyperparameter tunings. You are simply basic model you are taking. In that case, it will be underfitting case. In that case, what you can do? You can do a bit hyperparameter tuning, or you can go with proper model. You can go through different models, whichever the performing better. To that model, we can do some hyperparameter tunings, and you can tune the model. In that case, you will be getting the good fit. In that case, training accuracy and the testing accuracy will be near to equal. And if we are going through each and every data point, in that case, we will be calling it as a overfitting case. You are not the machine learning, whatever the machine learning algorithm that you are trained, it didn't learn anything, but it simply copied the whole data frame. And according to that, it will be giving the output. In that case, you will be getting training accuracy is always 100, mostly 100%, and sometimes you'll be getting 99, something like that. So this is the underfitting, overfitting. When you have underfitting case, in that case, the data that you are taking is not appropriate, or maybe not giving, not useful for the prediction. Whatever the output that you are predicting, it is not useful. In that case, what you have to do? You have to go and you have to collect the data, and then you have to add that feature into the data frame. Then only you can able to improve the model accuracy. When you have overfitting cases, what you have to do? You have to go for regularization techniques. You will be having some hyperparameters. You can tune those, and you can you can tune the model and you can improve the accuracy of that particular model. This is about bias and the variance. Yeah. Yeah. Like we have already discussed about the overfitting, what could be the overfitting, what exactly the overfitting, when will be overfitting happening. Let's say, yeah, decision tree algorithm is the best example when it comes to overfitting model. So what happens in decision tree? You will be having data frame. Whatever the decision that we are making based on yes or no condition, if else, it is a ladder of whatever the decision tree that we are building, it is a ladder of if else conditions. We simply go into that particular data, yes or no. In that case, we'll be splitting. Something like that, we'll be splitting. All those decisions, whatever the decision that decision tree is making, it is going through each and every data point. In that case, what happens? It will remember the whole data point, whole data frame. Then, if you are supplying, you are building the decision tree model. In that case, what happens? It will give you training accuracy is equal to 100%. The decision tree itself, it is bound to overfit. In that case, we will be having two regularization techniques when it comes to decision tree. What are those? One is pre-pruning, and next we'll be having post-pruning. So we are controlling the model. Pre-pruning is not recommendable, since we are judging before building the model or before building the tree. Once you can go with post-pruning. Once the model is tree building has done, whichever the unnecessary columns will be having, unnecessary branches will be having, that doesn't giving any information, any feature that are not giving information. If you are still build the model or still created the decision tree, you can simply cut those trees so that you can avoid the overfitting. So what happens overfitting? You will be having training accuracy. It will be high. Let's say training accuracy is about 80%, and you have training testing accuracy is just 60%. In that case, 20% difference will be having. So it is a clearly overfitting case. It is overfitting case. So that you can avoid using the regularization techniques, or you can do the hyperparameter techniques as well. Yeah. When we'll be calling the underfitting? A model or a machine learning algorithm is said to be have underfitting when it cannot capture the underlying trend of the data. So it is not machine learning, whatever the machine learning model that we are building, it is not able to understand the data or understand the patterns of your data. In that case, we'll be calling as underfitting. In that case, what we will be having? Training accuracy will be training accuracy itself low. You don't have enough data. In that case, you can add your data frames and you can build the model back. Like that, we can avoid overfitting and underfitting. Yeah. Yeah. These are the hyperparameter. These are the overfitting and underfitting cases, and how can we avoid those, especially in classification cases and regression cases. Any doubts? Yeah. So what did we discuss? First, what will be having this crisp ML. What are the phases we'll be having? Whatever the thing that we have discussed, just summarizing. What are the things that we have discussed? Crisp ML methodologies. What are the crisp ML methodologies? How many phases we'll be having? What are those phases, and what we will be doing in each phases? And then we'll be having different supervised learning, different machine learning algorithms that are, one is supervised learning and one is unsupervised learning. When it comes to supervised learning, how can we train the model? How we are splitting the data frame into different, whether it is training or testing, and how we are doing when it comes to unsupervised learning. And when it comes to supervised learning, what are the classes we'll be having, like classification and regression. In classification regression, what are the error function we'll be having? What are the error function when we will be having when it comes to classification? We'll be having confusion matrix. In confusion matrix, what we have, we will simply comparing what are the misclassified cases we'll be having, what are the correctly classified cases we'll be having. Based on that, we will be judging the accuracy of the model. When you have unbalanced data in the classification cases, what is the unbalanced data? If you don't have a proper representation of the class, if you have class something like this, S or no, these are the two classes we'll be having. Like, let's say you have 1,000 data frame. In that, only you have a 20% for no cases and 80% for S cases. It is a clearly unbalanced case. Here you have no classes, very less. The patterns are very less compared to the S classes. Whenever you're doing the segregation or you are doing the prediction, you can able to do the prediction for S cases very clearly, since you have more number of patterns. But when it comes to no cases, you don't have that many patterns. So you might be facing some difficulty to segregate or to predict that particular cases. In that case, what we can do, you can simply convert that unbalanced data, convert the unbalanced data into balanced data. For that, we'll be having different techniques, something like oversampling, undersampling, smooth. What happens in oversampling? Whatever the minimum, minority classes will be having. In this, what is the minority class we'll be having? No. When it comes to undersampling, whatever the majority classes will be having, we are decreasing into to make equal to the minority classes. In smooth technique, what we'll be doing? It is synthetic minority oversampling technique. What exactly it is? Name itself saying synthetic minority oversampling technique. Wherever you are having the minority class, we will simply synthetically creating the new data frames so that it can match to the majority class. So like that, we will be converting the unbalanced data to balanced data. Then we will be applying the machine learning algorithm. If you have not done the converting from unbalanced data to balanced data, in that case, you can't simply rely on the accuracy of the model. In that case, if you have unbalanced data, you can't simply rely on the accuracy of the model. In that case, you can go with the F1 score, that is 2 into precision into recall by precision plus recall. So it will balance both precision and recall. And then we have check, right? Once it is done in classification, we'll be having the evaluation metric in regression. In that, we'll be having different root mean square error, absolute mean square error, something like that. We'll be having different, but we'll be using the root mean square error. And like finally, we have overfitting and underfitting cases, and how can we avoid the overfitting and underfitting cases, that also we have seen. So that is it for today, guys. I hope you guys learned something. And if you want to kickstart your data science career, you can go through 360DigiTMG channel, 360DG YouTube channel, and there Tame Python. team Python sessions are already started. It's been over 5 days since the session is started. So if you want to kickstart your data science career, it is very compulsory to learn the Python session. So please, if you are interested, you can simply go and watch those videos. And yeah, that is it for today, guys. And in tomorrow class, we will be learning about what are the pre-processing techniques we'll be having. In tomorrow class, we'll be learning what are the pre-processing techniques we'll be having when it comes to structured data and when it comes to unstructured data. When it comes to unstructured data, you'll be having texts, something like that, and structured data, you'll be having tables. So how we will be doing the pre-processing when it comes to structured data, how we can do the pre-processing when it comes to unstructured data, all those things will be seen in next class. Yeah, that is it for today, guys. I hope you guys learned something, and yeah, we'll see you in the next class then, and have a nice day.